Okay, I'm going on to part D of this problem. And part D asks, according to the model from part C, at what time were the entries being processed most quickly? And since P of t is a rate of change, it's the rate at which entries are being processed. If we want to find out when entries are being processed most quickly, we want to find out when that rate is at its maximum point. And it happens to be an absolute maximum over the time interval from 8 to 12. You notice that we have a closed interval there. So we need to consider two things. We need to consider critical points and endpoints. So I say that P of t will be a max when P prime of t changes from positive to negative. So that's one thing we have to consider. And so one way of doing this is to go ahead and enter a derivative function for y1. And I do that by selecting math and deriv y1. That's vars, y vars, y1. Vars functions, y vars, y1. And my variable that I'm differentiating with respect to is x. And instead of putting a value that I want to find the derivative at, I put in x, which gives me a derivative function. Now, I'm only interested in the time when they're processing these entries, which is from 8 to 12. I'm not concerned about from 0 to 8 because they haven't started at that point. And I set my y min to be negative 10 and my y max to be positive 10. If I go to graph that, I can see that I have two zeros, or two critical points of that function. Those are the places where the derivative is 0. And I want to find those two zeros. So I do second calc, option 2 for 0, and I go a little bit to the left, enter, a little bit to the right, enter, guess, and it gives me the first one as 9.184. So you can see that I've set up my table, which I always do when I'm looking for an absolute min or max. I'm always going to set up a table with the endpoints and the critical values. So I have my first critical value, and that critical value is definitely a relative max because the derivative changes from positive to negative, so that's something I'm interested in. The second one is not so important, but I will go ahead and identify it. So I'm going to do second calc, I want another 0, and this time I'll start from 10 and go up to 11 and guess, and I get that at 10.816. Now that one I'm not concerned about because that's a relative minimum, but the other values I still need to find, and the way I'm going to do this is to go out to the main screen and to evaluate the function at those points, remembering that I'm talking about the original function, which is in y1. So I do vars, y vars, function, y1, and I plug in 8. And they're at 0. So at time 8, 0 entries per hour are being processed. Next, I do the same thing. I'll recall that, clear, I go second enter, and instead of 8 I'm going to put in 9.184, and I end up with 5.089. And finally I'm going to do again second enter, and this time put in 12 and delete the rest of that, enter. That gives me 8, which means 800 entries per hour. So they were processing the entries much more rapidly at 12 o'clock. And so I conclude my justification by saying that the max value has to occur at a critical value or endpoint, and it happens to be at time t equals 12. So again, this is just illustrating that we need to test the endpoints, not just the relative maximums, but also the endpoints. And that's it for this problem.